YouTube. This video is going to be about protein folding and what protein folding does and how it can help you and good stuff like that. So what protein folding is before your body can use the proteins, the proteins must be assembled. Where's my mouse? There it is. So here we have a protein that is right now going through some tests, and the thing with protein folding is that there's a program called Folding at Home where you can download. I'll put a link in the description. That what it does is it gives you a certain protein, and then it lets your computer fold it, and then it sends the results back to Stanford University for research. And what happens is that certain proteins that they think cause like Alzheimer's and diseases like that, if they fold wrong, like if it mutates or something, then that's what can create things like Alzheimer's and diseases like that. So what this does is it basically borrows your unused CPU time and it folds a certain protein that the Stanford University will upload to the client. That's why, hence the router to the laptop, which gives me internet connection. And you fold that protein, and then it uploads the results. So right here, I just have. I'll show you the computer I'm using. I'm using the server that we built a couple videos back that I've just put the program on, and I'm using it. This is also, just to let you know, if you're going to fold at home, you need a quite good computer to get it done fast. This is a server using a server, some server components. I've upgraded to ECC RAM, so I've got some good things on that, because what it does is it takes an extremely long time. I think it's like 2 days to simulate only about 12 milliseconds of protein folding real time, because all the variables that need to be calculated. So yes, it does put a lot of stress on your computer, and normally this thing doesn't go above 22 degrees, and as you can see right there, 27, 29, 33, yeah, it really stresses your computer out quite a lot. Sorry for the refresh. It's because of the monitor. And it's stressed the CPU to max. So how do you get this program? Well, I'll do it on my laptop here. You're gonna want to go to Google and type in fold. Oh, I can't spell fold. Folding at home. I just type in folding, and it's the first top on Folding at Home.me. And here it is. It's Stanford University, and there's different clients you can download. So go to the download section, and you can download it. It's multi-platform. You can download it for Windows, Linux, Mac OS X, even PlayStation 3. And that's just the client that, as you saw, does this on your CPU. But there's also a client. I think it's high performance clients. They're in beta testing, so I don't totally know if they work perfectly or not. Which use your GPU as which helps process it, and also you get a cool little simulation visual. But what I was going to say is that to do that, you need to have a CUDA compliant graphics card, like a good NVIDIA graphics card, or I think you can do it with ATI. I'm not sure. Let me see. No, it's not in there. List of available client. No. Where did I find it? or different types of clients. Aha. Then there's a console client and a graphical client. Clients page. High performance clients. Yeah, here we go. These are the high performance one. Required for Fermi. You need a Fermi. And oh yeah, here we go. Windows V6, GPU 2, ATI 2 and above, 2, 5 and above, and NVIDIA. If that made any sense. There's a bunch here. I think there's one for Linux, but it's for 64-bit. So you download this, and then what do? So what you're going to do is you're just going to install it, and then since it's already installed on this computer, you can go down here, type in, and you want to go configure. And the first thing where it says user, you're going to want to put your username, that just a username that you want to pick. It can be random. It just consists of only alphanumeric characters and standard punctuation. And you also may join a team, which team with your friends, and most of the time I just join team 0 because it's the default. At the top in connection, you can either put ask before using network, set a proxy server if you have a proxy server, or allow recipient of work assignments in return of results greater than 10 megs in size. Note that such work units may have large memory demands. So that's for like the really big ones. Advanced, you can do your the core priority, so lowest possible or slightly higher. CPU usage percent, you can set it to a lower percentage of the allowed CPU time. I have it set up to 100 because that's what I've dedicated this computer for. And checkpointing frequency, so you get checkpoints at a certain time. Do not lock cores to specific CPU, or pause work while battery power is being used for laptops. Then okay, and anytime when you're folding, you can go display, like I already showed you before with the molecule. Pause work, pause when done, or status. You can go to my folding. Wait for it to load, and you can see your personal statistics or team statistics. But I'm gonna go unitinfo.txt, and this shows the current work that you're doing. I'm doing an Alzheimer's disease amyloid. It's the Alzheimer's one. Download time, due date, and then progress. I'm at 18% right now, and this thing's been running for about a day and a half. And also you can see Q info, which is the ones that you want, that you're getting log files, user statistics, and team statistics about your folding. So I'm a big advocate of this project because you're doing your part to doing your part for research in certain diseases like cancers and Alzheimer's and stuff like that. The only requirements that you really need is a decent computer with that works really well, and internet connection. So I'll put a download link below, and thank you for watching.